Good afternoon, YouTube. I am pleased to present another video. This one is a little bit kind of niche for people that are messing around with GRBL, but so the basic idea is that when you first install your lead screws and your motors, I'm using NEMA 23s, and they have it's basically 200 steps per revolution of the motor itself, right? So when you want to calculate the step resolution, you need to figure out how far this machine moves in one revolution. So that can be kind of confusing if you're not really sure where to even begin or even what that means. But essentially what that means is, when, let's say you tell your machine to go 3 inches and instead it goes 3.5 inches, that means that your step resolution was wrong. The way that you correct this, the easiest way that I know of to correct this and to set it properly, is first you need to know how many steps your motor takes to go a full revolution. Like I said, mine is it's basically 1.8 degrees per step. So what you do is you take a full circle, which is 360, and you divide that by 1.8, and it basically tells you 200. So that's how I know that mine is 200 steps per revolution. So now that I know that is the steps that it's going to take, I need to know how far it's going to travel in order to go, or basically, so when it makes one full revolution, I need to know how far it's going to travel. The easiest way to do this is to simply measure the distance between each thread on your ball screw. So hopefully I can kind of show you down here. So you take calipers or something and you measure right in between. Mine has little grooves, so it works best to measure in there. So real tight measurement, I get 5 millimeters per thread. So that means every revolution this will travel 5 millimeters. So now what you need to do is you need to consider how many steps this is actually taking, because I have this step set for microstepping at a half step. So every step is half as far, which means there's twice as many steps that it has to take. So instead of 200 steps per revolution, suddenly I'm going 400 steps per revolution. So what you do is you take your initial full step resolution. So you know that the motor says 200 revolution, or 200 steps per revolution. You know that your ball screw has a distance of 5 millimeters per. Now mind you, this is for my ball screw, not yours. You should measure yours independent and find out what it is, but mine's 5 millimeters. So in 200 steps it's going to go 5 millimeters. So divide 200 by 5 and you get 40, right? So since I am now, so that's your full resolution. Now when you divide your steps in half, you double your resolution. So now instead of doing the doubling beforehand or whatever, it's best to do it after, I think, because now you take that 40 steps per millimeter and it becomes 80 steps per millimeter. So when you go to set your resolution, that's what you're working with. For your X, Y, and your Z, the step resolution is pretty much, if you're using the same ball screws, all with the same ball screw pitch, all with the same motors, then it's going to be the same. If you're using a different motor, it might have a different step to revolution count. So it might, like, basically the phase might be like, I don't know, 2.8 instead of 1.8 or something. Less resolution, higher resolution even, right? So given these factors, you need to be able to kind of figure that out and put it into your machine, because now you can go in, because originally the G-code sender was set with a resolution of 70 steps per millimeter. So when I would go and I would try and calibrate it, I had discovered that in 10 millimeters it was only going 9 millimeters. So that is the first sign. Like in 10 millimeters, if it's out a millimeter by the time it gets to the 10th, that's obvious enough. If it was any smaller than that, it might be hard to tell. You might have to go and oddly enough, the calibration was in millimeters, not in inches. I would have loved to went an inch or something and saw how far it went, but no, I had to do it in millimeters. So you got to kind of keep in mind that that's the case as well. You got to be able to measure in millimeters somewhat accurately. So if you're an inch person, then you might run into some troubles figuring that out. So to sum everything up, step resolution is important because that is a reflection of how far your machine goes as your motors turn, and your lead screws or whatever you're using causes your machine to travel. So if you have your resolution out of whack, then when you try to make a 5-inch circle or something, it's going to be a 5.5-inch circle instead, right? You want it to be dead on the money, and that means you need to try and calibrate it as best as you can. In the future, once you get things, more figured out, assuming that you are at the beginner stage like me, then yeah, everything will be much easier. But as it is, it's just important to keep in mind that all you need to do is measure the distance between the threads, and then divide your steps per revolution by that distance, and then multiply that final product, or I guess it's not a product, it's a dividend or divisor or whatever the hell it is. So yeah, so anyways, you take that the final result, and then you multiply it by however many steps. Let's say, because like my stepper drivers here can go up to 32, so I times 40 by 2 to get 80. But if I was at 32 microstepping, that's 6,400 pulses per revolution. So that's really high precision stuff, and I'm not sure the exact benefits in my scenario because I'm only going half step. But yeah, that would give you more torque, I guess, a lot more torque. But you would be slower, I guess. I don't know. Like I said, I'm a beginner on this, but I would just like to try and share some information. I had to kind of figure that out for myself, and I mean, it didn't take too terribly long. But I can imagine, without even knowing what step resolution means, it might take you a while to figure out what you're looking for. So yeah, hopefully I rambled out somewhat of an explanation for anyone else, and feel free to send me a message or post a comment with any questions. Usually if I don't know something, I can look it up pretty quick, and there's also lots of other videos to refer to on YouTube, but sometimes they're just not very clear. They're not very easily understood. So hopefully this is a easier explanation, because I couldn't really find a very quick and easy explanation. I'm not saying this is quick, because 10 minutes later here I'm still rambling, but if you got 10 minutes to sit down and watch a video, hopefully this explained it to you. That's one of the crucial points. I'm trying to figure out some of the other details for these motors, like they might have some specifics, like pulse duration or something like that. Their acceleration and deceleration rates I might be able to fiddle with those, but in the meantime, it's just good to know that it's going to travel as far as I want it to travel, and it'll have somewhat precise motions, right? Because that's pretty important for a CNC machine. So thank you again for tuning in. This has been another rant brought to you by Distant Vision. Yeah. Like, subscribe, comment, troll me, message me, whatever. If you're interested in this kind of stuff and you need some help with your project, then feel free to try and get in touch, and we'll see how things can be helped along, because I found that there's a lot of stuff I have been pretty slow on with this build myself, and maybe if I wasn't just doing it by myself, it would have gone a little bit faster. But progress is progress, right? I just think it's important to get the machines built, get working on them, and then you know, sky's the limit. Once I started with a 3D printer, I learned how to fiddle around with G-code with a 3D printer, just a cheap little one, and then I bought myself a cheap little desktop CNC machine. I learned how to do instead of an additive process, I learned how to do a subtractive process. I used different programs, learned how to use all the free stuff, and yeah, now I'm hoping to get my larger machine here going, and I can work on some larger projects. That's the goal, right? The goal isn't to sit here treading water for 20 years. You wanna get the thing set up, and you want to get working, pumping some stuff out, right? So thanks again for watching, and hopefully this has helped you. Have a great evening.